I am Mr. Ish and I welcome you to this video, part 2 video on hyperbolic computations, where we will continue to examine how you can do hyperbolics in terms of their computations and calculations without solely relying on the calculator. The calculator has a specific button HYP and that activates the hyperbolic function when you combine it with the sine, cosine and the tangent. If you do the shift button and then you combine it with the hyperbolic button and then the sine, cosine or tangent, then you're doing the inverse of this hyperbolic function. Hyperbolic function is something which would look like this: sine hx. Inverse of hyperbolic would be sine with that -1 exponent, and that would be your inverse. This is your regular hyperbolic, this is your inverse of that hyperbolic. You can activate the inverse by looking at this shift button, then doing this, and then clicking on the sine button. And that's exactly how you would activate the inverse. Anyhow, let's look at some calculations. These are important calculations that we should be able to do without explicitly utilizing this button on your calculator. For our first one, we look at something like this. If someone were to ask you to calculate hyperbolic cosecant and then the value here is 5, how would you go about doing it? It's not hard. You have to start with the definition of this. You know, this right here is the same thing as the reciprocal of that. And with that, you're looking here at the 5 coming right over here. And that's exactly what you're looking at. But it's not hard because you know the definition of hyperbolic sine. It's 1 over e to the x minus e to the minus x over 2. This right here would be the reciprocal of that. You flip everything around, you're seeing this. Now to get back to our question, you're just putting 5s in places of these x's. You have 2 over e to the 5 minus e to the minus 5. You would calculate this on your calculator. You can do the denominator first, then save that value, then do 2 divided by that value and you get your answer. I'll do this and I'll post the answer for you. You want to basically work from this direction right here in the denominator. You'll do a -5 and then shift, activate the exponential base. You'll add that to 5 with the exponential. This right here is your denominator which you're going to save. Then you'll do 2 divided by that saved denominator and your answer is 0.01347. That would be the answer of this question, 0.01347. But how can you prove that this answer is indeed good? Now just you can use the calculator and your function right over here, your HYP function. Hit 5 and then hit hyperbolic and then sine. And now do the reciprocal of this because we're looking at the reciprocal of a hyperbolic sine, and you get 0.01347, and that's exactly how you would do it. You would hit with 5 on your calculator, then you would hit the HYP button, then you would hit the sine button, then you would do the reciprocal of it. And that would give you exactly this right over here, and the answer would be 0.01347, and it should be good. Let's look at this. Hyperbolic cotangent with the value 2 being fed into it. What is the answer? This is coming here from a hyperbolic tangent. Hyperbolic tan. And you know that's coming from a hyperbolic sine divided by a hyperbolic cosine. You know that. But if you're looking at a hyperbolic cotan, you're looking at hyperbolic cosine divided by hyperbolic sine. That's exactly what you have. You would have their individual definitions. E to the x plus e to the minus x over 2 divided by e to the x minus e to the minus x over 2. These would cancel out. You would really have e to the x plus e to the minus x over e to the x minus e to the minus x. This right here is your hyperbolic cotangent function. But if you want to look at it in terms of what the answer is with regards to the 2 plugged in, you got to replace all of these x's with 2's. And that's exactly how you would proceed. And it wouldn't be hard, it would just be all calculator work if you are not going to use a HYP, the hyperbolic button, and then you'd work it out. You'd work here in the denominator, always from right to left, then you'd work in the numerator. I'll plug the answer here for you. We'll start here with the denominator. You'll do -2, shift, activate the exponential base. You'll add this to the 2 exponential base. This is your denominator value, save it. Now do again from the numerator, right to left, activate the exponential base and add this to 2 exponential base. Divide this by your saved value, your denominator. You're getting 1.037. And that would be your answer, 1.0373. But we have to check this answer is good, and we can check it by using the calculator. How would you do it? Just do 2, hit hyperbolic and hit the tan. That way you're activating hyperbolic tan with regards to that 2. But we're looking at hyperbolic cotan, so you have to do the reciprocal of it. do the 1 over x button, the reciprocal, and you get 1.0373, and your answer is good. So what are we doing here in terms of the calculator computations? We're starting here with the 2, then we hit the HYP button, then we hit the tan button, and that gives you your hyperbolic tan with regards to 2. Then you hit the reciprocal button, 1 over x, and you get this answer right over here, which is exactly here, and the answer is good. So this computation is good, but you can see not doing it with the calculator and doing it with the calculator are very different procedures. You should be able to do it this way, and you should be able to do it that way. Our last question is this. This is going to be an inverse hyperbolic question where you're working in the reverse. There's a certain value out there you have to find, for which if you were to plug it in, you would get a value of 1 over 2. What hyperbolic angle is there? If you did the hyperbolic tan, you'd have a value of half, or x is equal to inverse hyperbolic tan of that half. How do you go about solving this? Bring in the definitions of this. You have hyperbolic sine divided by hyperbolic cosine. Hyperbolic sine is this divided by hyperbolic cosine, which you know the definitions are these, is equal to 1 over 2. These 2's will cancel out. You're really looking at e to the x minus e to the minus x over e to the x plus e to the minus x is equal to 1 over 2. Cross multiply everything over here, and that'll get everything going. 2 will multiply over here. You'll have 2 e to the x minus 2 e to the minus x is equal to, this will multiply upwards, e to the x plus e to the minus x. Bring all the like terms on one side, or bring everything onto one side. Shift this here, shift this there, and equal it to 0, and then we can do that. I have 2 e to the x minus e to the x, I'll have e to the x. Then I have minus 2 e to the minus x minus e to the minus x will be minus 3 e to the minus x is equal to 0. Do a little bit of algebra here. You're looking at 3 over e to the x. Now do a common denominator. You'll have e to the 2x minus 3 over e to the x is equal to 0. How do I have this? I have a common denominator here of e to the x. 1 goes in e to the x times and multiplies with this. You have e to the 2x minus 3 over e to the x equals 0. Take this across. You really have e to the 2x minus 3 equals 0. Take the 3 across. E to the 2x is equal to 3. Now bring in the natural logs. 2x natural log e is equal to natural log 3. Natural log e is always equal to 1. X is equal to natural log 3 divided by 2. I'm going to bring it right here. X is equal to natural log 3 divided by 2, and that will give you your answer for this value here, x, such that if you did the hyperbolic tan of it, you'd get a value of 0.5. And let's find it. 3 natural log divided by 2, I'm getting 0.5493. But I'm going to save this value. 0.5493 is our answer here. X is equal to 0.5493. I saved the value right over here. Now let's test this out. I'm going to click on hyperbolic and tan, and I should get 0.5, and that's exactly what I do, and that's exactly what I get. So this answer is right. Now if supposedly you're presented with this question, you don't want to do all of this. How do you do this with just calculator strokes? These are how you would do it. Look at it in this way right over here. You'd click on 0.5. You'd enter 0.5 on your calculator. 0.5. Then you'll hit the shift. Then you'll hit the hyperbolic. Then you'll hit the tangent because it's going to activate the inverse hyperbolic by means of that shift. And you'll get 0.5493, which is what you have here. So your strokes are this: 0.5, you click on the shift button, then you click on the hyperbolic button, then you click on the tangent button. You'll get inverse hyperbolic tan of 0.5, which is exactly right here, inverse hyperbolic tan of 0.5, and your answer will be 0.5493, and the question is good. So I've shown you 3 questions in this video: hyperbolic cosecant, hyperbolic cotangent, and hyperbolic tangent, and now you're getting the idea of how these questions are done, utilizing the calculator and not utilizing the calculator. And that's it for this video. Thank you for watching. Have a good day.